All right, testing, sound check. Oh wait, I need to turn on my light.
Wait, your title's wrong again.
What? No, it should be right. Let me.
The email was wrong.
Oh yeah, the email. Yeah, that's because the email gets sent out before I got the chance to update the title. Whoopsies. Yeah, we're not doing Node today. We're doing databases. All right, we'll start maybe in like 2 minutes. Give some people time to come on in. Hope everyone's having a good day today. In the meantime, I'm gonna get my stuff set up. All right. Let's see. All right, let me go ahead and share my screens. All right, let me check if my. Nope, that's not working. Let me check if this is. Is this working? There you go. Okay, now you can see my keystrokes. Cool. All right, let me make this bigger. So as always, you can use the !/ slides command in chat if you want a link to these slides. Okay, cool. So we're about ready to get started. So welcome everyone. This is the 18th session. Wow, that's never really thought about how far in we are. 18 is a lot, and yeah, we're kind of nearing the end of the our full stack journey, so to speak. So today is a pretty big topic. It is. I don't want to say it's light by any means. It might lean on the heavier side, but that's okay. In this presentation, we've tried to dilute it down to the things you absolutely need to know about databases so that your head's not overwhelmed with topics and concepts. And as always, I always stress that like what you see and hear in the lecture, like that is important to know, but ultimately your knowledge of this particular topic will come about when you actually build something with it, and that helps build that deeper understanding. So we will do a little bit of a demo today. We'll kind of like set up a Next.js app with the database so you can see how that's all working together. But just a heads up that this session might be a little bit more challenging than last Thursday's session, which was a little on the lighter side. Okay, so our agenda for today is pretty straightforward. We're just going to be talking about databases, and just like the basics of databases and the many types of databases. And then we're going to talk about ORMs, which we'll explain in just a few minutes. We'll talk about a little bit about deployment of databases, some authorization and authentication stuff, and then we'll do a demo where we actually set up a live app. All right, so let's get started with what is a database. So a database is basically a structured collection of data that is stored and managed electronically. In web development, we use them to store, organize, and retrieve data, usually our users' data in our applications. And typically, databases are organized into tables, which can then be queried to retrieve certain types of data, right? And what you'll also often hear is that databases, there's like two ways to interact with the data, right? You can read the data, so you can grab the data from the database, or you can write the data, right? You can kind of think of this as similar to like GET and POST requests, right? GET requests are kind of like reading data. POST requests are kind of like writing data. So that's one way to think about it. And there are really three main types of databases. Actually, I don't know if it's fair to say there's three, there's probably more, but just for our purposes, we're just narrowing it down to these three main types. Like I'm not including stuff like Redis in here. So if someone brings that up, just know that I purposely did not include like cache databases because that's a little bit outside today's scope. But the three we're going to focus on today are relational databases, which are also known as SQL DBs, document databases, also known as NoSQL DBs, and finally graph databases. And if you are going to become a front-end and full-stack developer, which you pretty much are at this point, I highly recommend you get acquainted with relational databases the most. One, because they're the most popular. Two, because they're the most solid, I guess. They've been around for the longest time, and they still are super common in most production apps today. So yeah, definitely get comfortable with relational databases first, but in this lecture, we're kind of like going to talk about all three just so you have that knowledge in your head. But to be honest, I can't remember the last time I've worked with a document database. I think it was back in when I was in Bootcamp 8 years ago. Did I use like MongoDB and stuff like that? And I don't think I've ever really used a graph database. So yeah, basically all my real applied knowledge is on relational databases. So why do you need a database? So let's pretend you're building yet another to-do list app, and you might have already come into this problem, which is like if your users refresh their page or if they visit your app from a different browser or a different device, they will lose all their data. And to avoid this, you can store the user's account, so like their login and their sign up account and their to-dos in a database, and this will solve this, right? So if you have this data stored in a database, no matter if they come into your app from a different device or like refresh their page a billion times, that data is going to persist. It's always going to be there in that database. So that's why we, in web applications, typically if you have anything that has to do with login or user accounts, you pretty much always need a database. Okay, let's get started with talking about relational databases. So relational databases, they store data in tables, and these tables have rows and columns. The tables are connected to each other through the use of something called foreign keys, which you don't need to know entirely today. But basically, those are used to reference data stored in other tables. So the easiest example I can give is for a blog, right? If you think about a blog, maybe we can use Reddit as an example because Reddit is kind of like a blog. There are users, right? There are user accounts on Reddit, and then there are posts, right? And users can make posts. Right? When I go into reddit.com, log into my account and submit a post, that post is associated with my user. And that kind of association is basically how I can think of how these relationships are in the relational database, right? So maybe in Reddit's relational database, they have like a posts table, and then they have a users table, and they're connected to each other, right? So that's one way you can think of the relational database. And typically, this is not always true, but this is like a rule of thumb, kind of a weaker rule of thumb. But typically, when you would decide to use a relational database is when your data is highly structured. So in the Reddit example, right, the posts and the users have a natural relationship. So that is an example of when we would want to use a relational database. But the other rule of thumb is typically you want to use it when the number of rows is a lot more than the number of columns. So this might be hard to visualize now, but just know that if you're building an app where you're going to hopefully maybe have like millions of users at some point, or like a very, very, very long table, that is when you would want to use a relational database, right? When you have a very wide table and it's not very long, then maybe relational database is not the best choice. But typically, yeah, most apps, if you have any kind of natural structure and you expect there to be a lot of rows, then relational database is your go-to. And that's probably why relational database is the most popular by far, because most apps kind of fit that criteria I just described. So the programming language that's used to manage relational databases is called SQL, which you might have heard before. SQL stands for Structured Query Language. As web devs, I do not think you actually need to know SQL. You absolutely don't need to master it at all, but it doesn't hurt to know little bits here and there. I would say if you're going to focus on the back-end side of things, then you're probably required to learn SQL at some point. But if you're just starting out your front-end or full-stack journey, you don't need to prioritize learning SQL right now. And I'll talk about why in just a second. So some examples of relational databases include Postgres or PostgreSQL. This is my personal favorite. I've been using this one for God knows how long. It's probably the most popular production grade SQL database out there, so that's why I recommend it. So basically, if you're going to build something like a serious project or like a startup or for a company, Postgres is very common one you'll run into. Another very popular one is MySQL. MySQL used to be the most popular one, but I would say recently Postgres has kind of made a comeback in terms of how popular it is, but they're very similar, right? Like once you learn one of these three, these concepts apply to any of them. The syntax is slightly different between these three, but for the most part, if you learn one, you've kind of learned the other ones as well. So it doesn't really matter which one you pick for the most part. And finally on this list, we have SQLite. And as the name implies, this is like a very light version of SQL. It's the easiest and fastest to get up and running. And I recommend this one for small projects. And I think in today's demo, we're going to be doing something with SQLite today just because it's so fast to get up and running. Like you don't need to download anything to get SQLite running, whereas you do need to download Postgres or MySQL to get it running on your computer. So that's why for today, we'll use SQLite. Okay, let's talk about document databases now. So document databases, and these are also called like NoSQL or non-relational databases, they store data as document models rather than structured tables. I tried to come up with a good analogy or example to explain this, but it's kind of difficult. But basically, it's like the opposite of relational databases, right? We want to use relational databases when we have a very defined structure and when the number of rows is greater than the number of columns. But the opposite is like you would want to use a document database when your data is very unstructured or when you have a very wide table, right? When your number of columns is a lot more than your number of rows. So examples of document databases include MongoDB. This is by far the most popular one. Another one is CassandraDB, which is, I guess, popular in more enterprise-sized companies, but I wouldn't say that popular for startups and stuff like that. And honestly, like for document databases, NoSQL was kind of this trend that a lot of bootcamps hopped on. Like a lot of bootcamps used to teach MongoDB as part of their curriculum. But to be honest, I feel like if you're going to invest time in working with one database, you pretty much should just spend your time on relational databases. And only if your application is extremely unstructured or like your data is extremely unstructured, then I would recommend pulling in something like MongoDB. So off the top of my head, what do I mean by unstructured? Well, let's say you're building like, I don't know, an app that involves web scraping, right? Web scraping is basically when you take data from a website, right? Let's say you want to, I don't know, well, you can't actually do this or you'll get banned, but let's say you want to scrape a lot of data from LinkedIn, right? Maybe like just scrape the whole page data. Because the page data can be unstructured, maybe you would want to dump that data into a MongoDB database or something. So that's off the top of my head one example of when you might use a document database, but even then, you could still probably find a way to use a relational database for that one. Okay, so now we're on to the most uncommon one, which is the graph database. So I've never actually used a graph database in production. I've used them for when I was doing bootcamp projects, like back in the day. But yeah, this is definitely the most rare database that you'll see. And that's because they're only really useful if your data has a natural graph structure. So an example is like if you're building the next Facebook, right? Facebook has a graph structure because friends you can think of as nodes, right? That connect to other friends, that connect to groups and so forth, right? If you visualize Facebook's data, it kind of looks like this graph structure. So they use a graph database to manage that. So basically, unless you're building something like Facebook, you probably don't want to choose a graph database for your application. And the most popular type of graph database is Neo4j. And I try to think of other ones, but honestly, they're all so uncommon that it was only really worth mentioning Neo4j here. But once again, you don't actually need to know all this about graph databases. Just know that there are three types, right? Relational, document, and graph databases. And what you will want to focus on, or at least what I recommend, is to focus on the first one, relational databases. Okay, so let's now talk about ORMs. So ORMs is one of those acronyms in web development that you might hear and see before, but you might not actually know what it means. I personally had to look up what it stands for because I always forget what ORM stands for. So it stands for Object Relational Model. And what you can basically think of the ORM as is it's basically a connector between your web app and your database. So remember how I said relational databases use SQL to like query the database and all that? The reason why I tell web developers you don't need to know SQL, at least not right now, is because the ORM handles that for you. Like when we use an ORM in JavaScript, we can write JavaScript and the ORM will translate that JavaScript into SQL for us, which is really nice, right? Which just means we can just keep our application in one language, JavaScript or TypeScript, and the ORM will do all the heavy lifting of actually reading from and writing to the database. So that's nice. So there are many types of ORMs out there. The one I recommend is Prisma. And this is the one that we're going to be using for the rest of the bootcamp. Prisma is extremely popular right now. And it's very flexible. Like it works with pretty much all relational or document databases. Like it works with MongoDB, it works with MySQL, it works with Postgres, it works with all of them, which is really nice. And it's type safe. This is a term that we haven't really talked about yet, but we'll talk about it on Thursday when we start TypeScript. So keep an eye out for that. But yeah, Prisma is basically my go-to for any kind of production project now. Prisma is just with how unwieldy most ORMs are, Prisma is a blessing. It's definitely a lot easier to use, I would say, than other ones. And yeah, it's just extremely flexible, which is nice. Some other ORMs you might encounter are Mongoose. Mongoose is typically used only with MongoDB, as the name might imply. So, in a lot of older web apps, you might see like Mongoose with Express connected to a MongoDB database. This was like the bootcamp. This was like the web dev bootcamp stack of like 2015, basically. So it's not that popular anymore. But if you're going to use MongoDB, then you can either use Mongoose or Prisma. Two other ones that I thought were worth mentioning here are TypeORM and Sequelize. These are also ORMs that were once popular back in the day. And by back in the day, I mean like 5+ years ago. And honestly, Prisma has just been so dominant that I can't imagine like what are the pros of using TypeORM or Sequelize over Prisma. So yeah, I'm here to tell you that Prisma is basically what you want to get used to. Okay, so let's talk about deployment now, because this is definitely something that's worth mentioning. So as you know, here in the bootcamp, we don't talk about deployment all too much because the thing I always go to is Vercel, right? Vercel has just made it so easy to deploy web apps. But the thing about databases is that you cannot deploy a database on Vercel, at least not yet, maybe one day. The database is something you have to deploy separate from your web app. So how it works when you're building an app with a database is that in development, you would typically run your database locally. So like you would run your database on your computer, basically, on your local computer. And when you actually deploy your database and take your app to production, you need to find a site or service that hosts your database, right? You need some kind of service that keeps your database running all the time. And this is typically done separate from your web app, right? Because we're going to use Vercel most of the time to host our web app, and we need to use another service to host our database. Typically, this costs money, which is unfortunate, right? Like I know Vercel has spoiled us and made it so that we can deploy apps for free, but typically there aren't a lot of services that won't like require you to pay for the database. But as of recently, as of like a few years ago, there has now been a couple of startups that have launched that offer free plans, which means now it is possible in 2023 to deploy a full stack app with a database for $0, which is great. And I narrowed those options down to really three choices. So Railway, this is a new one. Railway allows you to basically deploy a database. It's not for free, but they give you like $5 of free credit, which is more than enough to leave your database running all month if you have very little traffic, right? So if you have a small app, like a small project, Railway is a great choice. Supabase is another great choice. Supabase basically not only takes care of the database hosting, they also take care of like authentication, so like user management and all that. So Supabase has a lot more pieces attached to it, but I think it's like even cheaper than Railway. They have like a pretty generous free plan, so that's pretty great. And the third option I gave is Firebase. Firebase is very similar to Supabase because Firebase comes with its own database and user management. But honestly, I'm not too much of a fan of Firebase. Firebase is one of those things that like a few years ago, Firebase was like the best option if you wanted to host a database for free because there were just like no competitors at the time. But now Supabase, which was designed to be a direct competitor to Firebase, and Railway, now that those are more popular and established, I find it hard to argue for Firebase just because of how, well, one, the documentation is very outdated. Two, it's just not super type safe, TypeScript friendly, and it doesn't, just not like a ton of examples working with Next.js, etc. Like Firebase is a fine option, but I'm going to say right now, like generally I would go with Railway or Supabase for hosting a database in 2023. Okay, now let's talk about auth. So auth is a very, how do I say it? Auth is a very heavy topic because authorization and authentication is very complex. But at the same time, it's one of those things that you pretty much always need for your app, right? If your app has any kind of sign up or login buttons, you need authorization and authentication. So auth basically describes the process of letting users sign up or log into your app. And this is probably one of the most common reasons to use a database, right? Without a database, you can't store that login information and those account information. So if you have anything like that, you need a database with auth set up. And the thing about auth is that, sometimes, like everything in programming, you can build it out yourself. But my question would be like, why? Why would you ever build out your own authorization system besides just to learn how the whole thing works? Even then, it's just a painful process. And thankfully, there are a lot of libraries that handle it for us. The number one choice on this list I recommend is called auth.js. Technically, it's still called NextAuth. I put FKA as like formerly known as NextAuth because they're in the middle of changing their name to Auth.js. But if you hear me call it NextAuth, then just know that auth.js and NextAuth are basically the same. And yeah, I recommend this one. It's simple, very flexible, and it works amazing with Next.js and Prisma. So as you can see, there's this trend of which technologies I recommend, right? I like to recommend technologies that work well with the other technologies in our stack. So just a pro tip there. Another one I put on this list is Passport. Passport is the one that was extremely popular maybe like 3 to 5 years ago. Typically, you would see like the Passport, Express, MongoDB stack for the backend. But Passport is just like, it's just not as simple as auth.js. And yeah, this one just has lost kind of popularity just because there are just better solutions now, like auth.js. But I thought it was worth mentioning here just in case you do run across that word Passport at some point. Supabase I put on this list here because, as mentioned on the previous slide, Supabase comes with their own auth solution. So Supabase isn't just a database. It also comes with the authorization included, which is really nice. So it's good if you don't want to deal with too much complexity. If you just want one service that handles all your auth, all your database, then go with Supabase. And another thing to mention about all three of these is that they've made it extremely easy to add whatever provider you want. And by provider, I mean like, let's say you want to add login with Google on your app, login with Discord, login with TikTok, login with Twitch, right? Login with email or password, right? Any of those things are providers. And dealing with providers is insanely difficult if you're building out your own auth. But if you use any of these three libraries, they have all included ways to make it super easy to add that stuff to your app. So that's why I recommend using a library. And if you do want to read more about the crazy, complicated world of auth, I recommend checking out this article by Okta, which they talk about OAuth, which is basically one of the protocols used for like a lot of Google logins and Facebook logins and all that. So recommend checking that out and giving it a skim if you dare. Okay, so talking, that was a lot of talking. Now let's actually go and kind of play around with a code base with some auth in it, not just auth, but a database in it so we can kind of see what that looks like. So here I have linked a repo So this is a repo from Prisma and Next.js, which is basically it's a full stack example with Next.js. And they basically have Next.js, React, Express, and Prisma, right? All things that we like here at this bootcamp. So I went ahead and just found this example, and we're gonna basically go through their instructions and get it set up on our own computer. And then we'll just spend the rest of today's session just like walking through the folder and just talking about kind of a lot of the topics that we encountered in the slides. So go ahead and let me share this in the chat if you don't have access to it. Cool. So I'm going to go ahead and follow their examples here. We need to first download this example, this template, and then we're going to CD into it. So let's go ahead and get our terminal up. Okay, so I'm going to CD into our bootcamp folder, CD projects, CD bootcamp projects. All right, don't put that here. Make this a little bigger. Okay, let me copy and paste this command. Paste, enter. Okay, should we automatically install packages for you? Yes. Which package manager do you prefer? To be honest, I like PNPM now because it's super fast, but you know, not everyone has that installed, so let's just go with NPM. What should a project be called? Yeah, that's fine. I'm just gonna leave the name. And we want to create it there. All right, so that should take a few seconds. Let's let it get set up. Okay, cool. All right, it's ready to go. So now we just have to CD into the repo, and let's also open it in our text editor as well, or code editor, sorry. So I'm gonna open up my code editor. Where did it go? Oh, there it is. I'll just keep it on the right here. All right, I'm gonna open up this folder that we created. So open folder, bootcamp projects, yep, here it is. Yeah, yes, I trust. Okay, cool. Let's open our terminal in VS Code as well, just so we have that open. Make this a little bigger. Close this. Okay, cool. So before we run any commands, like always, I like to do a quick tour of the code base. So as you can see, we have a lot of, we have the pages folder here, right, which tells us that we're using Next.js. You should be somewhat familiar with this. And where I really want to start is the Prisma folder. So the Prisma folder is where you're going to hold the schema. And the schema is basically a file that tells you what tables are in our database. So we'll talk about it in a second. We also have the seed.js file. A seed script is basically a script that loads your database with data, right? When you spin up a new database, typically it's empty, right? There are no rows in it. But the seed database basically creates a bunch of dummy data or like starter data, and it populates your database with it. So that's what the seed script does. Finally, we have this dev.db-journal file. So this is a file that's used by SQLite, right? Remember, SQLite is one of the relational database types, and SQLite is what we use if we're building like a small project or like a quick demo, which is what we're doing here. So this file, like I'm not gonna click on it because it's gonna be like a weird, like I don't think we can really like see the content. It's a weird structure, but this file basically is your database. We can think of files and folders as essentially like stores of data, right? When you create a document of text, that is kind of like a database, and that's basically how SQLite treats data. They store all the data in this file, so that's why it's so light. Cool. So let's go into the schema now, and let's do a quick walkthrough of that. So I'm going to click on schema.prisma right here. The syntax is kind of ugly, right? Everything's whited out. So it was very kind of VS Code to tell us, hey, we have extensions that can help with Prisma files. So we probably want to download the Prisma syntax highlighter, which will actually highlight the syntax in this file, which will make it a lot easier on our eyes. So I'm going to go ahead and install it. So yeah, if you click the extension here and click install, I'm going to go ahead and install that really quick. Okay, cool, it's done. Let's go back to our schema file. Okay, nice. It's no longer ugly. It is colorful. So where to begin? Let's start from the beginning. So generator, client, provider. This is basically just saying like what is the name of your provider. That's not super important. This is a little bit more important, the data source DB. This is basically saying what kind of database do you want Prisma to connect to. So in this case, we're using SQLite, right? So that's why we say provider SQLite. If we were using Postgres, this would be Postgres. If we were using Mongo, it'd be like Mongo or something, etc. But we're using SQLite, so let's stick there. And then because we're using SQLite, we need to have a file URL, right? Remember how I said SQLite stores data in a file? This is basically saying, hey, point us to the file that you're storing data on. So file, and then you give the path to the file. So in this case, even though it's dev.db-journal, it still matches this file pattern. So it's going to recognize that this file is where we're going to store the data. Okay, so this is all like configuration stuff. Now this is the actual schema under this. So model user. So this is right here is basically saying we have a user table, like a table of users, right? And each row has 4 columns: the ID column, the email column, the name column, and the posts column. So let's talk about these really quick. So the ID, every table in SQL should have an ID column. I can't think of many examples when you don't want an ID column, but the reason why we have an ID column is because this is how the database and our app will know that each row is unique, right? And by default, it says right now our ID is set as an integer, so the IDs will be like user ID 1, user ID 2, etc. We give it this special ID syntax, and we say by default auto increment. So this basically means every user that gets added to our user table, their ID will be the previous ID plus 1, right? So user 1, and then another user signs up, their ID will be user 2, right? So forth. So this is pretty standard that you'll see on a lot of schema setups. Okay, let's talk about the next column, the email, right? This makes sense. Every user, if they're going to use email to log in or create an account, they should have an email field, right? This is what the user's email is. And one other thing we can do here is if you don't want 2 users having the same email, which is probably what you want, you can add this unique decorator here. And unique will basically say that if there are 2 users with the same email, throw an error, right? So it's basically just not going to allow that another user with the same email to sign up. So this can be very useful. And then we have the name column, right? So if the user types in their name or signs up with their name will go here. And as you can see, just like the email column, it is a string column, right? So only strings will be allowed in this field. And the other thing I want you to notice here is this question mark, right? This question mark that is next to the string. So when you see this question mark after the type of data in the SQL, in the schema, this means that it's optional. So question mark means optional. So this is saying that, hey, even if the user doesn't have a name, it's okay. It's an optional field. So one might ask, like, why is this optional? Well, sometimes when a user signs up with only email, maybe you don't care so much about getting their name, right? If they sign up with Google, you can automatically get their name from their Google account, right? So in scenarios like that, the user that signs in with Google might have their name populated for them, while the user that signs in with just email and password might not have a name by default. So that's why it's optional here. Okay, so now we get to the last column, posts. And posts, this column is going to have a relation to another table that we have. So posts is made up of a list of other posts. And this post is referencing another table, right? So back to the Reddit example, right? Let's pretend this is like the data model for like Reddit, right? My user would be in this table, and in every post I make, it would create a new row in here and then connect it in the posts column. So let's now talk about the post table here. So once again, same as our user table, we have an ID column, right? Every table, once again, should have this ID column most of the time. Another thing we have is these two columns, created at and updated at. So by default, created at will just be the time that a new post was created. So it defaults to now, basically the time when the post was created. Updated at, whenever any of these fields are updated after the post has been created, this updated at decorator will automatically say, hey, this post was last updated at this time. So it handles that for us. And then we have the title of the post, the content of the post, which in this case is optional, just in case we want to allow posts with only a title and no content. There's a published, and then as you can see, the type for published is Boolean, and by default, it's false, right? So this will let users have draft posts, right? Let's say you start typing a post, but you don't want to publish it. By default, that published flag will be false. And maybe you can have an option in your app to let them publish it, and this will be set to true. View count, which is going to be an integer, which starts at 0. So this might be like how many views a post gets. So every time someone views the post, maybe we increment this view count column. And then finally, this is where we have our connector back to the user column, right? We have the author, right? Every post will only have one author, basically. And in this case, it's optional, right? So I guess this is saying that some posts might not have an author. We know this because of this optional flag on the user. But if the post does have an author, then there will be this relationship between the user table and the post table, where let's say I create a new post, the author of that post will be my user account. And then we also need an ID field for that user. So author ID is basically just the user ID that created the post. And this author column is it contains the user data itself. So this might be kind of confusing, but once we get into the example, hopefully this will make a little bit more sense. But basically what I want you to get from here is that here we have a very simple schema setup, and this line right here is what's connecting multiple posts to a single user, and these two lines right here is what's connecting a user to a single post. There's a lot more to talk about in terms of these relationships, right? There's like, I don't want to overcomplicate things right now. It's like a whole other world. But hopefully this is using the Reddit example. If you think about Reddit, this will start to make sense a little bit more. Okay, cool. So that's the schema. Maybe let's go over the seed data really quick before we start to run any scripts. So let's click on the CJS. So yeah, like I said, remember seed. Let me close this terminal really quick. So like I said, the seed file, the seed script, is basically used to populate our database, right? So as you can see, in this file, we have an array called user data. And check out user data, like what it looks like. User data is an array of objects. And each of these objects represents a row that we're going to create in our database. Specifically our user database, right? Because this is user data. So as you can see, remember in our schema, we have a name column and an email column. And in the posts column, check out in our seed database what we have. Name, Alice, email, alice@prisma.io. And then the posts property is an object. This might be kind of weird, but this is like a Prisma thing. And basically, inside this post object, we have this create key, which is equal to an array. And this array is the list of posts that are going to be associated with this user. So in this case, Alice just has one post. And this is the post. And the post has a title, some content, and it's, in this case, the published flag is set to true. So weird syntax, right? Especially this create stuff, but this is Prisma specific way of saying, here's how you create a post for this user. So hopefully this will get a lot more comfortable as you start to write more of this. But I remember when I was learning Prisma, this was very confusing. So just wanted to point that out. Okay, so the next user that is in this user data array is Nilu. So Nilu has their name and their email, and they also have posts. But this time, instead of just the title, content, and a publish flag, let's say we also want to give them some views on their posts already. So view count is set to 42. And another thing I want to point out is that let's talk about data types really quick. Notice that the data types have to be exactly the same as what they are in a schema, right? This view count cannot be a string like this. And we know this because view count in our schema is set to be an int, right? Integer. Integer is a number type. And typing here, we haven't really talked about how typing is important yet because JavaScript doesn't enforce that. But when we're getting to databases, typing is very important, right? It will literally not let you add this row to the database if the type is wrong. So you have to pay very close attention to make sure that the data you're adding is the same type to what you've declared it as in the database. And once we get to TypeScript, this is going to make it a lot easier. But for now, just start to pay attention to like the typing of the data. Okay, cool. So moving on, we have another user here, Mahmoud. We have their name, their email. And this time we have 2 blog posts for them. One of the blog posts has a published and view count. The other blog post, we are leaving the published and view count off, which means it will just default to the values that are set in the schema. So as we can see, the view count defaults to 0 if it's not set, and the published flag defaults to false if it's not set. So that's what the values on this one are going to be. And that's it, right? So we just have these 3 users, and each of these users have maybe like 1 or 2 posts that they're adding. And then the rest of this file is basically saying what to do when the script is run. So here, this main function, it actually does the seeding. So let's check out what it does. So we have a for loop that loops through the array. So for each item in user data, basically, for each item or each user in user data, this is how we actually write to our database. So check it out. We call await prisma.user.create. And we know it's .user because the schema has declared this model as user. So when you have a schema like this means you can do prisma.user or prisma.post, right? Because we only have those 2 on Prisma. So in this case, we have prisma.user, and then they have a create method, which will actually let us pass in the data that is associated with each user. And then if it's created successfully, it's going to console log that it's created this user. So yeah, basically, and then we just run this function, and this is what's going to actually feed all this data in this list into our database. So let's do this right now. Let's go ahead and create our SQLite database file, which I think, yeah, it's going to create that database file for us. I guess maybe this one is like a placeholder. I'm not sure if this is the database file, but it looks like we have to create our own. So it looks like we just write the script. So npx prisma migrate dev -- name and init. So let's go ahead and try that. So I'm opening my terminal. I'm going to paste in this command. Okay, so it says, so let's check out what it's saying here. Prisma schema loaded from our schema.prisma file. And then it's going to create this dev.db for us. Okay, so it just created that for us. And it's applying this migration. So migrations, oh man, how do I explain this? Migrations are basically, what's the easiest way to explain this? Migrations are more intermediate to advanced. I will just say that off the bat. But basically, the migration is a script. So if you click in the migrations folder, notice that it just created this migrations folder. If we click on this migrations folder, you can see that there's a migration.sql file. Remember how we talked about SQL is the language of databases? This is what I mean by, this is what the ORM really handles for us. In the ORM, we've basically written this like JavaScript-like syntax, right? Same with the C data. This is all like, object syntax. And basically Prisma, by running this command right here, it translates this data structure into SQL queries. So this is basically creating our user table and creating our post table in the SQL language, but we didn't have to write SQL, right? It's basically done it for us. So that's essentially what's going on there. So yeah, it's really nice. That's what I mean by like you don't need to really understand SQL. Like it is nice in case of emergency to be able to go in and understand like what's going on in these files. But for the most part, as long as you have the right structure in the schema.prisma, then you don't really need to know SQL right now. Okay, anyways, so basically after it's created that migration, then it ran the node prisma slash c.js. So it basically ran this file. So as you can see, it logged this start seeding command right here. And then it created our 3 users. And you can see that they've been assigned automatic IDs like 1, 2, and 3. And then it finished. So that's basically it. And this means in our databases, in our database, we right now have 3 users and 1, 2, 3, 4. We have 4 posts. So 3 users and 4 posts. That's what we have in our database so far. Okay. So now let's see, now let's actually run our app and see if we can see this data in our application. So it looks like next we run npm run dev. So let's run that. Okay, so started server. This looks like, yeah, spinning up our Next.js app. So let's go to localhost 3000. So we get, okay, so check this out, right? So this is a blog example, my blog. And as you can see, the blog, it has a list of posts. And as you might notice, some of these posts, or actually all of these posts are related to what posts we have in our seed database or our seed script, right? Notice that we only have 3 on here, but we're supposed to have 4 posts. Remember that one of the posts was not published. So I'm gonna guess that that's why we're missing 1 post. So yeah, so this one's published, this one's published, this one's published, but this one's not published. So this must be the missing post right here. But because we have 3 posts that are published, we see 3 posts on our front end. So let's see, what else can we do here? Oh yeah, if you click on drafts, okay, so we see that missing post that's in drafts, right? Because this is not published. And if you click on it, you can see we have the option to publish it, which clicking this will basically set the published flag of this post in our database to be true. So let's click it. Okay, so it's out of our drafts, and now we can see that it's published. But as you can see, now this is basically the easiest way to see how the database comes together with our full stack app, right? We can sign up for a new account. So in this case, I'm just gonna say Zach, and then just add my, actually I just use my playground email, sign up. Okay, so I just signed up for a new account, and then I can create my own draft. So it'll be like, hello, author email address. So in this case, I guess they make me manually write my email address. Test post create, and by clicking create, it's basically going to add a new row in our post database that's associated with my email address. Hello, and right now it's not published. So if I publish it, it shows up on the main blog. It's very simple, right? This is basically a super simplified version of a blog or Reddit, like that, those kind of applications. And you can see how Prisma lets us actually do something like this, right? Without Prisma or without a database, all this data, like when I refresh the page right now, it would disappear, right? If we didn't have a database. But because we have a database that persists this data, you know, even if I log on a different browser or like on my mobile device, you know, we'll still see our posts here. So there you go. Cool. So what else does talk about here? Yeah, I think that's all for now. But hopefully, like basically, once you start playing around with this repo by yourself, it'll start to make a lot more sense how everything's coming together. But let's see, if we had an easy way to like look into our database, that would be nice. maybe we could run Prisma Studio. Prisma Studio is basically a tool that lets you peek inside the database, right? As you can see, like if I click on our database file, VS Code complains that it's like a weird format, so it's not going to let us easily see the data. Well, let's see if we can use Prisma Studio to let us look into the database. So we can run this command, npx Prisma Studio, and maybe this will let us peek inside our database. I don't know if this is going to work, but let's try it. So I'm going to run npx Prisma Studio, enter. Okay, so the studio is running. Oops, wrong browser. So it's basically run. It's run this other web app, and this web app basically allows us to look inside our database. And it looks like this web app is running at localhost 5555. So if I go into our browser and paste localhost 5555, okay, cool. So as you can see, this lets us peek into our database very easily, right? We can see that we have our posts table in our user table. Right now they're called models, but you can think of models and tables as like basically the same. And we click on the post table, you can see that we have 5 rows, right? You can see the ID, you can see the created at, you can see the title, you can see the content. You can even edit it in here if you want. Like if I change this, you can just save it, if you want to update the data. And you can see if we go into our app and I refresh the page, our posts have updated. So it's nice if you want to be able to just like edit the data, but I found it very useful to just like peek into the database. So this is really useful when you're developing an app and you don't have any idea what's in your database. Well, you can just use Prisma Studio and it lets you peek inside. And notice here that we can see the user the author property on each of the posts, and you can click on the user and it shows you, it pulls up like the user table, which you can then open in a new tab and see, the actual row for the user. So yeah, Prisma Studio is pretty great. It's like very convenient to be able to just go in and like look at your database and just see, how many users do I have, how many posts do I have, all that stuff. And yeah, it just gives you a very easy visualization of your database schema, right? Okay, cool. So this is the simplest example of databases I can think of. And Prisma might seem like a lot. It is. I'm not gonna discount that. Prisma can be kind of complex, but as you can see, like once you get used to this way of working with data models, it's very, 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 very powerful. It's very easy to create very complex applications with a lot of data models using this schema file. So, all right, cool. That's it for the demo, basically. Let's talk about homework. So we've rolled out 2 new modules on the Playground app. We've added the databases in Prisma module, which you can learn a lot more in-depth stuff about, like Prisma queries, relationships, mutations, like optimization, stuff that we didn't get the chance to cover today. So that's been added. The other module that we also added was the TypeScript module. If you want to get ahead of Thursday's session, then I encourage you to do that one as well, since the databases Prisma module is a little shorter. But yeah, really, if you can just do the databases one, that will put you in pretty good shape for Thursday. And that's on the Playground web app. All right, so that's basically it. Hopefully that wasn't too bad. I know there might be some questions circling around your mind, but if you do have any, please let us know in the chat. But besides that, hopefully, if you got nothing out of today, just know that we're going to be getting used to working with Prisma and relational databases in our application. And yeah, if you followed this example that we went through today, hopefully it should give you a more solid idea of how all these concepts work together. Yeah, I'll take some questions, but if no questions, then we can go ahead and wrap up for today. In the meantime, I'm gonna post this example one more time in the chat, just in case anybody didn't get it earlier. And I'm also going to share Prisma Studio, in case you want to check that out as well. And then I guess the final thing I'll say before we move on and talk about TypeScript on Thursday is that, the types that you see here in our schema, if we think about it, only the database knows about these types, right? So if you if you push like a new row to these tables and it doesn't match up the type, the database is going to give you that error, right? But on Thursday, when we introduce TypeScript, the reason why we like to use TypeScript is because TypeScript will let us know, will basically tell the entire app what the types are for our database. So this makes it so while you're developing, your editor will tell you like, hey, this isn't the right type before it's even run. So this is super useful because this basically saves you time of debugging when you put your app in production and things break, right? TypeScript's philosophy is like, we have things break when you're developing rather than when the app is live in production. Because errors that are caught by you as a developer are a lot easier to manage than errors that are caught by your user. Also, your users will probably get angry if they get lots of errors. So that's one reason why we use TypeScript. So TypeScript is going to be also a little bit of a heavier session. It's going to be a lot of new stuff, but I think since we're already kind of learning about types like this, like how strict types are in databases, I think that philosophy will carry pretty well when we talk about TypeScript, because TypeScript is basically the same way. It just has these types for JavaScript. Is essentially how you might think about it. All right. I'm trying to think if there's anything else I missed. Oh yeah, when you also go through this app, we didn't talk about it today, but you can skip the front end stuff because you're probably pretty familiar with front end at this point. But if you check out the API folder in the pages folder, you can see the actual backend endpoints that you're using to delete, create, and publish posts. So I encourage you to walk through and look at that code, because that's going to give you a better idea of like how Prisma is being used in the backend here. All right, so no questions. I think that's a good sign. Can't really tell. I'm sure you will have more questions when you work on it on your own, but for now, I'm going to take that as a good sign. Cool. Thank you, everybody, for joining. I think that's basically it for today's session. So this session and last Thursday's session are going to get uploaded onto YouTube today, I believe. So yeah, so if you do want to review that stuff, and you're wondering why it's not on YouTube, well, just wait a few hours and it should be there. But cool. So I think that's basically it. So yeah, on Thursday, we're going to talk about TypeScript. And then next week is where we're going to start to put everything together. And I mean everything, right? Like we're going to put together Next.js, TypeScript, Prisma, basically the whole full stack. And we're going to build a more advanced project with AI. So that's going to be fun. Next week, we're going to start kind of wrapping up the main curriculum, the bootcamp, and let you all start to work on your more advanced projects and maybe even prepare for getting a job as well. So we'll talk about that more next week. But yeah, thank you everyone for joining. Hopefully today wasn't too rough. And as always, if happy to talk in private on Discord if you prefer that. But if no one else has any questions, I will see you all Thursday then. All right. Take care, everyone.